Hey, and welcome to The Explainer. Today, we're talking about a single device that seems, well, almost magical. It can both heat and cool your home. It's called a heat pump. You've probably heard of them, but how on earth do they pull off this seemingly impossible trick? Let's dive in. To really get your head around a heat pump, just think about this one question. What if that air conditioner that keeps you so nice and cool all summer could just run in reverse? Because honestly, that, in a nutshell, is the brilliant idea behind the heat pump. It sounds kind of crazy, right? One single machine doing two completely opposite jobs, shoving hot air out in the summer and then somehow finding heat to bring inside during the winter. So how does this super clever device actually do it? That's exactly what we're going to break down. Okay, first, the most important rule you need to remember. And this is true for your air conditioner and even your refrigerator too. These things don't create heat or cold. They are just really, really good at moving heat from a place where you don't want it to a place you don't mind it being. So, to figure out how a heat pump moves heat into your house, we first have to do a quick refresh on how a regular old air conditioner moves heat out. And it turns out they're both using the exact same playbook. The whole process is this constant four-step dance. Step 1, you take a special gas or refrigerant and you compress it, you squeeze it, which makes it get super hot. Step 2, that hot gas releases its heat outside your house and condenses into a liquid. Step 3, you force that liquid through a teeny tiny opening, which makes it intensely cold. And finally, step 4, that super cold liquid boils back into a gas inside your house. And in doing so, it soaks up heat right out of your air. Then the whole cycle just starts all over again. So here's the key takeaway. You've got two main parts, these things called coils. When you're cooling your house, the indoor coil is the evaporator. That's the part absorbing all your heat. And the outdoor coil is the condenser. That's where all that heat gets dumped outside. Now remember those roles, because they're about to get very interesting. Right, so if a normal AC can only move heat in one direction, out of your house, how does a heat pump work both ways? Well, the whole secret lies in one incredibly clever and surprisingly simple part. It's called the reversing valve, and the best way to think of it is like a little traffic pop for that super hot gas that's blasting out of the compressor. With just a tiny little electrical signal, this valve can completely change the path that hot gas takes. It decides whether it goes to the coil inside your house or the one outside. And that one simple change of direction, it flips everything. This is the big aha moment. In cooling mode, your indoor coil absorbs heat. But when you switch to heating mode, that exact same indoor coil now releases heat. The reversing valve makes the indoor and outdoor coils completely swap jobs. Let's walk through it, starting with summer. Okay, so let's start with summer, cooling mode. This is going to feel pretty familiar because it works just like any standard air conditioner. The mission is simple: get the heat from inside the house to outside the house. So the reversing valve, our little traffic cop, directs the hot gas to the outdoor coil. That coil gets really hot, and a fan blows air across it, releasing all that heat into the summer air. The refrigerant then flows back inside, gets crazy cold, and the indoor coil soaks up all the warmth from your home's air. Mission accomplished. Heat moved out. And the result is something we've all felt. You stand next to your outdoor AC unit on a hot day, and you can feel all that hot air blowing out. That's literally the heat being rejected from inside your house. And of course, inside, you're getting nice, cool air from the vents. Simple enough, right? But now for the magic trick: winter. Heating mode. The moment your thermostat calls for heat, a tiny electrical signal zaps our traffic cop, the reversing valve, and tells it to flip the entire flow of heat. And boom, there it is. With one little click, that valve shifts. Now, instead of sending that super hot gas from the compressor outside, it sends it to the indoor coil first. And this one tiny change makes all the difference in the world. So now, that hot gas makes your indoor coil the new heat source, warming up your home. The refrigerant then flows outside, where it becomes intensely cold. And this is the wildest part. Even on a freezing day, there is still heat energy in the outside air. Because the refrigerant is now so much colder than the outside air, it can actually absorb that ambient heat before it heads back to the compressor to get squeezed and start the cycle all over again. And this table here just makes it crystal clear. Now, if you go stand by the outdoor unit in a winter, you'll feel cold air blowing out. That's because the unit is absorbing every last bit of heat it can find in the outside air. And inside, you're getting warm, cozy air blowing out of your vents, the exact opposite of summer.
So in the end, when you boil it all down, it all comes down to this one key component. That little reversing valve allows the entire system to perform this incredible role reversal, turning an air conditioner into a heater. It's just a beautiful, elegant piece of engineering.
Which, of course, leaves us with one big question. Because a heat pump moves heat instead of creating it by, say, burning fuel, it's an incredibly efficient two-in-one machine. So with this one super clever trick at its core, you have to wonder, is the heat pump the future of how we all keep our homes comfortable?